Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about the coal fields of India. Remember, coal is a very important mineral for any country. Coal is used for power generation as well as it is used for production of steel. Therefore, coal historically has been very important for determining the economic prospects of any country. If we see the global production, then China is the leading producer of country by a very big margin, where India is on the second position. These are the coal mines across the globe. We can see that there is very huge concentration of coal mines in China as well as in India. Within India, if we see the coal reservoirs, then Odisha, Jharkhand and Chhattisgarh, these are the three states which has highest coal reservoirs within India, followed by West Bengal, Madhya Pradesh and Telangana. And then we see here that these states have very less amount of coal reservoirs. And if we see the states based on their production, remember in the previous slide we saw the coal reservoirs. In this slide we are seeing the annual production of coal. Then we can see that Odisha leads the states in production of coal. Remember in the previous slide we saw coal reservoirs. Here we are seeing annual production. So in annual production, Odisha is the leading state, followed by Chhattisgarh, Jharkhand and Madhya Pradesh. And then we have Telangana, Maharashtra, West Bengal, Uttar Pradesh, Assam and even Jammu Kashmir produces some amount of coal. So let's first understand how coal is formed. The process of formation of coal starts over here. There is a swamp, there are plantations, there are trees within this swamp. Over the time, the plants and trees will die and they will get buried within this swamp. Now because of this swamp, they will not get easily decomposed. And this will allow several layers of soil to be formed over them. Over them, sufficient amount of soil layer will be formed over these layers. Because of this overlying layers, there will be temperature and heat exerted on this layer, and the undecomposed body of these plants, they will be converted into some form of coal. Here we can see the timeline. For 100 to 400 million years ago, the swamp was there and the plants were buried. Then 100 million years ago, it was converted to peat. And then after 100 million years, that is in current time, we can mine it in the form of coal. So this is how coal is formed. Here is another example where we can see that there is stagnant water, and this is the layer of organic matter, that is the undecomposed plants and trees. Now with time, a sediment layer is formed over it, and this layer, which was this much thick, is now compressed to form peat. Over the time, this will further get compressed because of pressure of the overlying rocks, and it will form lignite. And if time further passes, then we will have bituminous coal. This is the distribution of coal across India. We can see that the major concentration lies here in the Chota Nagpur Plateau region and in the Godavari basin as well as in Mahanadi basin. Here on the borders, we also see that there are some coal mines. Here we can see that the coal fields are located in river basins. We can see here that these coal fields are located in Godavari basin. In Odisha, the coal fields are located in Mahanadi basin. In Jharkhand, the coal fields are located in Damodar basin, while here in the upper Chhattisgarh, we see that the coal basins are mainly around Son basin. And it is because we have seen earlier that the vegetation should be buried in a swampy land. So these river basins, they provided sufficient swampy areas for burial of these plants, which later formed into coal. Now if we see the time, pressure and heat over time, then we can see that here when the plants and trees, their undecomposed body are buried, and then over the time they are heated by the temperature and they are subjected to pressure by the overlying rocks. So if it is subjected to heat and pressure for millions of years, it converts into lignite. If it is subjected to heat and pressure for hundreds of millions of years, then from here it converts into bituminous coal, which is better than lignite coal. Here there will be higher concentration of coal because they are more compressed. And then finally in 280 to 360 million years, we see formation of anthracite coals. This has highest density of carbon and they are much harder than all other rocks. Now if we see the conditions for formation, then for anthracite, it should be more than 5 km and the temperature should be greater than 150 degrees Celsius. For bituminous coal, the depth should be between 1 to 5 km and temperature should be between 50 to 150 degrees Celsius. Subbituminous coal is a type of bituminous coal where the water content is higher and the carbon content is lower. And then we have lignite where the depth should be less than 1.5 km and temperature should be around 50 degrees Celsius. And if we see the characteristics of each of these coal, then we can see that anthracite has 86 to 98% of carbon by weight. So it has very high concentration of carbon. And it burns in boiler slowly and releases large amount of energy over time. Very small amount of anthracite is found in India in Jammu and Kashmir. Then we have bituminous coal. Here we will see that it has carbon content of 70 to 86%. It is lesser than anthracite. This can be used in steel plants as well as in power plants. And in India, we find it in Jharkhand, Odisha, West Bengal, Chhattisgarh, Madhya Pradesh, Andhra Pradesh, Maharashtra and Telangana. Slightly lesser in grade is subbituminous, which has lesser carbon and more moisture or more water. And it is having less efficient source of heat in the boilers. Therefore, this is rarely used in steel production. We find them in Jharkhand, Odisha, West Bengal, Chhattisgarh, Andhra Pradesh, Maharashtra, Telangana and Madhya Pradesh. And the least quality of coal is lignite. Lignite has 70% water content and around 20 to 25% of carbon. It emits more pollution from each of these coals and it is found in Tamil Nadu, Gujarat, Jammu and Kashmir, Sikkim, Nagaland, Assam, Meghalaya, Arunachal Pradesh and Darjeeling. Now if we see anthracite within India, then we can see that it is found over here in Jammu and Kashmir in very small amount. It is found in the district of Rajouri and the seam is spread across Riyasi and Udhampur district of Jammu and Kashmir Union Territory. If you see bituminous coal, then we can see that it is mainly concentrated here in the Chota Nagpur Plateau region and then we have it in Madhya Pradesh and in Maharashtra. If we see subbituminous coal, which is the most abundant form of coal in India, we can see that it is concentrated in Godavari Basin, in Chota Nagpur Plateau region, in Rajasthan and in Assam, Arunachal, we also found some amount of subbituminous coal. And then if we see the lignite, we can see that lignite is found over here as well as in Gujarat, Rajasthan, in Jammu and Kashmir some amount of lignite is found in Srinagar Valley and then we have in Assam as well as in Tamil Nadu. While studying, we often come across the term Gondwana coal and tertiary coal. So let's try to understand what does this term mean. We've already seen that the type of coal that we will get depends on the duration for which the layer is subjected to heat and pressure. So, millions of years ago, the period on Earth was called tertiary period, while hundreds of millions of years ago, the period on Earth was called Permian period. And 280 to 360 million years ago, the Carboniferous period was there on Earth. So if a plant was buried during the tertiary period, then that layer will lead to formation of tertiary coal. Now because this coal has been subjected to only millions of years of heat and pressure, so it will be of lower quality. That is why tertiary coals are generally lignite. Here, the plant layer which was buried will be subjected to heat and pressure for hundreds of millions of years. So the plants which were buried in Permian period, they will form Gondwana coal. And because it is subjected to heat and pressure for hundreds of millions of years, they will form bituminous coal. And that is why the Gondwana coals were formed by the plants which were buried in Permian period and they are generally of bituminous or subbituminous type. And here again the plants layer which was buried in Carboniferous period will form anthracite rocks, but they are generally not found in India. Now here are the major differences between Gondwana coal and tertiary coal. These differences are obvious from what we have discussed earlier, that Gondwana coal was formed during Permian period that is around 250 to 300 million years ago, while the tertiary coal was formed during tertiary period around 15 to 60 million years ago, that is during the formation of Himalayas. Now, the Gondwana coal has high carbon content because it is subjected to pressure for higher duration and therefore it has high calorific value. Here, there is higher moisture content and lower carbon concentration, and this is because this layer of plants was not subjected to sufficient pressure for sufficient duration. They have lower sulfur content. Sulfur content is very important in coal. If the content is higher, then it will produce more pollution. It also harms the machinery. So lower the amount of sulfur in a coal, better that coal is. In tertiary coal, we get higher sulfur content. We have already seen that Gondwana coal is generally bituminous or subbituminous, while tertiary coal is lignite or peat. These Gondwana coals can be used for coking, that is, for converting the coal into coke, which can be used for steel production. Here, these coals cannot be used for steel production and they are used in power generation or for domestic purposes. Here, we can see the distribution of different types of coal in India. The red color indicates bituminous coal. These pink color dots indicate the subbituminous coals. Yellow color indicates lignite coal mines, and here we can see anthracite coal mines. Here are the coal fields indicated in this purple color, and within these coal fields we have these coal mines. So these coal fields are basically coal seams in the ground in which there are coal present, and these are the places, these dots represent the places where we have mines to extract coal from these coal seams. Here we can clearly see the coal seams across India. We can see that coal seams are there in the Chota Nagpur plateau region, in the Mahanadi basin, in Godavari basin. Here in Tamil Nadu we have a coal seam, then in Gujarat, Rajasthan, Jammu Kashmir, and in the northeast we have coal seams. Now here are the division of coal seams based on Gondwana or tertiary. Here we can see we have tertiary coal fields. Here also we have tertiary coal fields, but here we have Gondwana coal fields. So we see that in the Chota Nagpur plateau region, in the Mahanadi basin, in the Godavari basin, we have mainly Gondwana coal, while in the northeast and in the western states, we see generally that there is tertiary coal. Even in Tamil Nadu and Jammu and Kashmir, we see here that there is tertiary coal. Now let's try to understand the difference between coking coal and non-coking coal. We have already discussed that coking is a process of converting coal into coke. Here, coal, especially bituminous coal, is heated at higher temperature without air. Now, because of this, what happens that all the volatile elements which are present in the coal, the volatile elements could be moisture, hydrogen, or some other elements. So these elements are evaporated and they exit the coal, and the carbon concentration of coal increases, and therefore it releases more energy. So this coke is then used for steel production. Here is the main difference between coking coal and non-coking coal. It has higher carbon content, it has low carbon content. It has low volatile matter like moisture. It has higher volatile matter. We have seen that it has higher moisture. It can be converted to coke, it cannot be converted to coke. It can be used in steel production, this cannot be used for steel production. Almost 90% of coking coal in India comes from Jharkhand. And within Jharkhand, the Jharia coal field produces the best quality of coal. Here we can see the distribution of coking coal and non-coking coal fields. The yellow color indicates coking coal fields, and we can see that they are fewer and concentrated in the Chota Nagpur plateau region and in this Madhya Pradesh, while most of the other coal fields produce non-coking coal. Here we can see the distribution of coal reservoirs within India, and we can see that highest coal reservoir is in Odisha. But Odisha mainly produces non-coking coal, while the coking coal mainly comes from Jharkhand. We have already seen that 90% of coking coal in India is provided by Jharkhand. In fact, prime coking coal, which is the best form of coking coal, is provided only by Jharkhand. The coal reserves for prime coking coal are only present in Jharkhand. Other than this, Chhattisgarh, West Bengal and Madhya Pradesh have some amount of coking coal reserves. Here if we see the coal reserves of Jharkhand, then we can see North Karanpur has highest coal reserves, followed by Rajmahal coalfield. But Jharia has the best quality. We can see that prime coking coal is only present in Jharia, and more than 50% of the coal reserves in Jharia are coking coal reserves. So the best quality of coal reserves come from Jharia coalfield, and then we see that East Bokaro and West Bokaro also produce sufficient amount of coking coal. Now let's see state-wise coal production. Starting with Jharkhand, these are the coal fields in Jharkhand. They are spread in the central region of Jharkhand. And here is also there is a coal field which spreads between Jharkhand and Bihar. These coal fields are mainly located in Damodar River Valley. We can see this is the Damodar River and these are its tributaries. These are the names of these coal fields. Here it is Daltonganj, Uttar, Auranga, South Karanpur, North Karanpur, West Bokaro, East Bokaro, Ramgarh, Jharia, Raniganj, Devghar, Girid and Rajmahal. Now Raniganj is mainly located in West Bengal, but very small part of Raniganj is in Jharkhand. And this Jharia coalfield is located in Dhanbad, and that is why Dhanbad is famous for coal production. We have already seen this chart where we indicate the coal reserves of Jharkhand, and we can clearly see that most amount of coking coal comes from Jharia, then East Bokaro and West Bokaro. Even though in terms of the total coal reserves, we have North Karanpur which has highest coal reserves, followed by Rajmahal, Jharia, South Karanpur, East Bokaro, West Bokaro and so on. Now let's see Chhattisgarh. Chhattisgarh has coal fields mainly in northern Chhattisgarh, and we can see that they are distributed between the Mahanadi River Basin and Son River Basin. Here we have Sohagpur. The Sohagpur is shared between Chhattisgarh and Madhya Pradesh. Here we have Tattapani, Ramkola coalfield, Sonat, east of Bisrampur. Bisrampur coalfield is also there. Then we have Korba, which is an important coalfield of Chhattisgarh. Then we have Mand Raigarh. This is also an important coalfield of Chhattisgarh, and we have Lakhanpur. If we see the coal reserves, then we can see that Mand Raigarh has highest coal reserves, followed by Korba, Hasdo, Aran, Tattapani, Ramkola and then Sonat. Sonat produces some amount of coking coal. Now let's move on to Madhya Pradesh, where we can see that it has Pench Kana coalfield. Sohagpur, remember Sohagpur is shared between Chhattisgarh and Madhya Pradesh. We have Umaria, Johila. This Sohagpur is in Sadhol. Then we have Singrauli coalfield, which is located in Singrauli district, and it is shared with Uttar Pradesh, which we can see over here. The Sonbhadra district of Uttar Pradesh is present over here. So this Singrauli coalfield is shared between Madhya Pradesh and Uttar Pradesh. If you see the coal reserves of Madhya Pradesh, Singrauli coalfield has highest amount of coalfield, but the coalfield generally is of non-coking type. Then we have Sohagpur, Pench Kana, Johila, Pattakira, Umaria, Gurunda, Mohpani. Now let's move to Maharashtra, where we can see that Maharashtra mainly has coalfields on the eastern side, starting from Kempty, Umrer, Makar Dhokra, Nand Bhandev and Varda Valley. Out of these, Varda Valley has highest coal, followed by Kempty, Nand Bhandev and Umrer. All of these produce non-coking coal. Then there is Odisha. The main coalfields in Odisha are Thalcher and Ib River coalfield. This Ib River coalfield is located on Ib River, which is a tributary of Mahanadi, and this Thalcher coalfield is located on the basin of Mahanadi River. Both of these coalfields, they generally produce non-coking coal. Then in West Bengal, we have Raniganj, Birbhum and Darjeeling. Remember, these two are Gondwana coalfields, while Darjeeling is basically a tertiary coalfield. It produces tertiary coal and they produce Gondwana coal. Here we can see that Raniganj has highest amount of coal and it produces some amount of coking coal as well, and that is why Raniganj is also an important coalfield. Then in Telangana, we have Godavari Basin coalfield. Here we can see this is the Godavari river basin coalfield. Godavari river flows through it. And in the northern part of the Godavari coalfield, we have Singareni coalfield, which is located in Telangana, and it is an important coal producing region of Telangana. Here also mostly we see non-coking coal in Godavari coalfield. In Andhra Pradesh, we can see again this is the Godavari river basin coalfield. It is shared between Telangana and Andhra Pradesh, and it is located in Godavari river basin. It also produces mainly non-coking coal. Then we have Bihar. In Bihar, we see Rajmahal coalfield, which is shared between Jharkhand and Bihar. And this is the only coalfield located in Bihar, and it produces mainly non-coking coal. Then we have Uttar Pradesh. We have already seen that Singrauli coalfield, which is shared between Madhya Pradesh and Uttar Pradesh in the Sonbhadra district of Uttar Pradesh. And this also produces mainly non-coking coal in Uttar Pradesh. Then in Meghalaya, these are the major coalfields. The Langren coalfield is the most important coalfield of Meghalaya, and then we have Siju and West Darangiri. All these coalfields are located on the southern side of Shillong Plateau. Here we have Garo Hills and here we have Khasi Hills. These all fields produce tertiary coal, and Langren has the highest coal reserves in Meghalaya, followed by Siju and then West Darangiri. These are other important coalfields of Meghalaya. Then we have Assam, where the most important coalfields are Singrimari, Mikir, Dili Jaipur and Makum. Makum is the most important coalfield of Assam. These coalfields, they produce tertiary coal, while Singrimari, it produces Gondwana coal. And here we can see that Makum, Dili Jaipur, Mikir Hills, they all produce tertiary coal, while Singrimari, it produces non-coking coal which is of Gondwana type. Then in Nagaland, in the northern region, we have lots of smaller coalfields, and their name are over here, and they all produce tertiary coal. The production quantity is very less. Then we have Arunachal Pradesh, where on the eastern side we have Namchuk Nampuk coalfield and Mayobam coalfield. And we can see that Namchuk Nampuk has highest coal reserves compared to Mayobam. Then in Sikkim, we have Rangit Valley, where lignite coal or tertiary coal is produced. In Tamil Nadu, we have Neyveli coalfield, and it is also producing lignite coal or tertiary coal. Within Gujarat, we see coalfields in Bharuch district, in Bhavnagar district, and then in Kutch district, and all of them, they produce lignite coal. Again, in Rajasthan, we see Barmel lignite field, Nagaur lignite field, and Bikaner lignite field. So all of these fields, they produce tertiary or lignite coal. Within Jammu and Kashmir, we have Udhampur and Kalakot coalfield and lignite series in the Srinagar Valley. Here we see lignite coal, and here we get anthracite coal in very less quantity. So with this, we will conclude our video. I hope you liked our video on the coal fields of India. Do let us know in our comments if you have any doubts. We will try to resolve it. If you have liked the video, then do share it with your friends and subscribe to the channel. And if you like what we are doing, then you can support us using the Paytm ID. Thanks for watching the video.